Hello guys, Fro here. Welcome to today's video. So in today's video, we're going to look at this very interesting concept of indexes and a zone map, or indexes and zone maps. So in the database world, you might come across the idea of indexes for getting performance and speeding up queries. And zone map is something that I think is less known than indexes, but it's also very common in certain database platforms like Netezza for query performance. They all try to achieve the same objective, which is to speed up queries. So if you are kind of wondering, what exactly is an index versus a zone map, where it kind of makes sense, this video is going to break down for us with certain examples that I have here on the screen. So as we go through, I'm going to be comparing and contrasting. Obviously, I don't think one is necessarily better than the other. They do have their benefits and maybe drawbacks, all right? And I'm going to cover some of those as we go through today's presentation. So that said, we're going to start here on the left side to talk through indexes. And then on the right side, we're going to talk through the zone map. And the example I have here on the screen to just make sense of this is just imagine going to a grocery store to do shopping. So that's going to be the example that I'm going to use to kind of build those similarities and differences between these two very interesting concepts from the database world. So assuming this is you, let me pass this to the side. You are going to a grocery store. All right, let me actually draw an individual here. So that's you going to a grocery store. You have your list of items you want to buy, right? So these are your list of items you want to buy from the grocery store. So maybe rice and fish and grapes and peas and bacon, right? You write out your list and you go into the grocery store. Now, at the grocery store, I've just kind of simulated the grocery store floor here. We do have aisles where we put our stuff in the grocery store, where the grocery store stores the items. So if you look at this, this first aisle here, aisle 1, has milk, eggs, and cheese, right? 2 has rice, beans, peas. 3 has flour, butter, salt, right? Fish, meat, bacon, paper, spoon, forks, juice, Coke, Pepsi, apple, oranges, grapes, and then salt, pepper, and garlic. So this is not completely random. There is some sense to that, and I'm going to talk through how everything is laid out. But let's assume you're going to the grocery store, you have your list, and you walk up to the door of that grocery store. What is the first thing that someone could do, right? The first thing that you might want to do is assume that there was some lookup table or there was some index, right? This is where index is coming from. Or some table of contents, if you think about it from a book perspective. Something that you can just look up and say, all right, where are X, right? And it says 1 here. So what if you read this, it's saying that X are on 1. So X are on row 1. So I can go to row 1 and I can see my X. All right. And then it goes down everything the grocery store has with a reference or with an index to where you can find it. So if you want apple, all right, apple is on row 7. So I can go to row 7 and I can get my apple. So this is what an index will look like, all right? In the database world, an index is basically just like a lookup table. So like a lookup table that you can go to tell you where your data is. So it's just a lookup table. You can create an index on any table. In this case, we can have an index for our grocery store. And if we have items on our list, we look at the index and we go to the store to pick up what we need. So now let's see how an index could be used if you are really going to shop from a grocery store. And I'm going to walk through the example. But more importantly, as we go through that, you're going to start seeing maybe the benefit of an index, but implicitly you're going to start seeing some drawbacks. That's why people sometimes are not fan of indexes on tables, because it can get really, it might not give you exactly what you want, right? So let's say we come in. The very first thing we need is we need rice, right? All right, I have my index. I'm starting at the very beginning at the door of the grocery store. And well, I need rice. So what do? Okay, I go up to my index and I look for rice. It says rice is on row 2. So I walk all the way to row 2 and I go in here and I pick up my rice. All right, so I walk and I go to row 2 and I pick up my rice. All fine and good. All right, so what else do I have on my list? I go back, I look at my list. Well, I need fish. So I look at my index. Where is fish? So fish is somewhere on, where is fish? Based on the index, I believe fish is on row 4. All right, so I walk all the way to row 4 and I pick up fish. All right, so that's all fine and good. So here, let me actually put a number 1, 2. All right, so that's the second thing. The third thing, what do I need? I need grapes. All right, so I look up grapes on my index. Where is grapes? Grapes is on row 7. All right, so I kind of walk down all the way to row 7, right, and I pick up grapes. So this is the third time. So all the way to row 7, and I go into the aisle and I go pick up my grapes. All right, now what if what else do we need? We need peas, right? I can go back again, look at my index and say, all right, I need peas, right? Peas, according to the index, is on row 2. So I leave from here and I walk back all the way to row 2. We were there before. All right, and I pick up my peas. So here, 4, right? So this is the 4th time we're walking. And then what do I need? I need bacon. All right, so after peas we need bacon here. So where is my bacon? Does the index tell me where it is? The index will say bacon will be on row 2 or row 4. All right, so from here I walk all the way to row 4 and I pick up bacon. So that's number 5. All right, so you can start seeing what's happening here, right? If you had a long enough list, it will probably be, if you get into the grocery store at 8 a.m. in the morning, it might be 4 p.m. in the evening before you leave getting what you want, right? It's just kind of round robin of moving around and picking things up. Clearly, you can start seeing that it's problematic, right? I started from 1, I moved to 2, moved to 3, back to 1 and to 2, and you can just keep dancing and playing this game here for a very long time. So even though the index looks great from the beginning to tell you where exactly you can go to get data, you can clearly see that there are some challenges with efficiencies. All right, in the terms of database, in the database world, we're doing a lot of scanning. Right, we're doing a lot of scanning. This is a problem. All right, and when you scan, there is this idea of you're wasting a lot of IO resources, right? Because I'm going here and I'm coming here, I'm walking back here and I'm exhausted and I'm going back there and I'm just scanning all over the place. That is really a problem. That's a problem for indexes. So that might be a drawback for indexes. Now let's look at what a zone map would be. A zone map wouldn't be in every database system that you come across, right? There are some database systems that have the concepts of zone maps. Some don't. So I'm going to talk first through what the zone map is, how it could look like, and then we can talk through some databases that will support that. So I'm going to use red for zone map. So assuming that, again, we started on the right side here, this is you, and you come into the grocery store willy-nilly, everything is great. All right, and you still need to shop for your items. How do humans actually shop, right? There are certain efficiencies that humans do that this is not the way humans shop. At least this is not the way I shop or people I see shop. This is not how it works. All right, this idea of indexes. So there is something different that people actually do. And what does that look like? So let's say we need rice, again, fish, grapes, peas, and bacon. Now, most grocery stores, at least in the US, and I believe around the world, most grocery stores, they realize this problem. And so what they do is they actually put in cards, right? If you look at the grocery store, like you might look at this and say, all right, milk, eggs, and cheese. What if we just say, all right, that is the dairy aisle. This area contains dairy, all right? And then this one contains let's just call it a starch, right? I can't even get a term for that. Let's say flour, butter, salt contains baking, right? So this is our baking zone. This is our starch zone. This is our dairy zone, all right? This one we can say this is a protein zone, all right? And then here, this we can say this is a utensils zone. This is a zone for utensils. And then drinks, and we can go with fruits in this zone, right? Apple, oranges, grapes, and then salt, pepper, garlic we can go to with spices or seasonings. All right, I'll just use spices there as an example. All right, so now assuming that we had a grocery store that you walk in and you had this kind of ordering, all right, how can this help us with certain efficiencies when we think about zone maps? All right, there are definitely some efficiencies here. So let's look at how that would look like. So if I come in here, I'm not necessarily looking at my index as such. I'm looking at my zone map. All right, so in here, this was the index. In here, this is my zone map, and I'm just gonna call that ZM. All right, so let's start. And I say, all right, I come into the grocery store and I start from the top here, and I'm gonna walk my way all the way down. All right, I'm gonna start from here, and I know I'm gonna walk all the way down. But you might look at it and say, isn't that very inefficient if you're just walking through every single aisle instead of going to get what you need? Let's see how that will play out. So I start from here and I'm going down. The interesting thing that we'll notice in this case would be, even though I'm walking down, I'm going to skip areas that I don't need. So if I don't need to get drinks, I don't have to go to the drinks areas. And the way I know that I don't need drinks is if I know I'm in the drinks zone or the drinks map of the place, I can just simply skip that. So let's see how this works with our list. Starting with rice. So if we look at rice, do I want rice? All right, I'm walking. I'm here in dairy. All right, what are the dairy items that I need to pick? Well, interestingly, I don't need any dairy items, so I can just go ahead and skip dairy, right? And starch, do I need starch? Yep, so I need to stop by the starch area, okay? And so I can go ahead and know that on that area for starch, I'm going to cross off peas on my list, and I'm going to cross off a rice from my list. So I just go in there, pick my peas, pick my rice, and I'm done. All right, and I keep going down. Do I need to do any baking stuff? I don't need any baking, right? You can even imagine having to, like if you come in here, you can just say, all right, what is rice, right? Rice is starch. I'll put S there. Peas is starch. Fish is protein, P. Bacon is protein, and grapes is fruit, right? F. So I know, all right, baking, I mean, there's no baking on my list. I can just skip that. I'm not even stopping there, all right? And I keep going down. Is there protein on my list? Yep, there is protein. I stop there and I check off the things that I need for my protein on my list, all right? And so let me make a dot here. So this is 1, 2, and then I can going. All right, do I need utensils? Well, there's no U on my list, so I can just simply skip that. All right, drinks, I don't have any drinks on my list. I can skip that. Fruits, yep, I have some fruits on my list, which is grapes. I can know to make a stop at grapes. All right, and this is my third stop. And no spices, I can just simply skip that and I'm done. All right, let's make sure we check that. So if you take a look at this, what you'll notice is with this idea of a zone map, even though it seems from the onset like I'm going to walk across the entire store, but the efficiency that you get with this is you can actually skip chunks of areas that are not relevant for you. All right, so here I'm just making 1, 2, 3 stops, and I get everything I want or everything I need. Whereas here with indexes, if you're not careful, you can be going back and forth and going to rice and then coming back to fruit, and it could really just be a complete mess. Now, if your list was sorted in a specific order, right, where you were smart enough or you had a way to sort your list to say, all right, I'm gonna start writing my list from everything from rice and everything from proteins and such. If you had that kind of a list, sure, you might maybe get some efficiencies with indexes, because you just know when you're in rice, you just end up picking everything from there without having to leave that area. All right. Same thing even with with the idea of a zone map. If this list is sorted, you just know to pick all the stuff. But sorting for you here is not even as relevant as it is here, because you are checking in this zone. I want everything for my list that is in this zone, basically. So even if this list is not sorted, you're still going to scan this list back and forth to say, all right, I need everything in this list that's in this zone. So these are some of the differences. Hopefully this kind of gives you give you an idea. In the world of databases, indexes and zone maps, you probably come across that at some point. More so for indexes, depending on the platform you're working with, you might come across zone maps. So in here would be Netiza, right? Netiza is really one of the appliances for that does this. I believe Snowflake as well, right? I heard Oracle is doing something like that. I'm not 100% sure for zone maps now, but here for sure Oracle and SQL Server and almost all the traditional databases that you know, RDBMSs, would give you some form of indexes, right? A lot of your traditional databases will give you some form of indexes. But zone map is another approach that when you think about, especially huge MPP kind of platforms, MPP kind of database that needs to do a lot of analytics. You can use zone map to help a lot, so you don't have to do a lot of scanning and a lot of I/O. This is if queries are taking a long time. Sometimes it's just because you might go into the store and you say, why am I taking a long time, or why is she taking a long time, or he taking a long time at the grocery store. It could be because they're kind of just being inefficient at the way they look for data, right? Same thing with databases and queries. If your query is taking a long time, it could just be a lot of scanning and inefficiencies based on design, based on how everything is structured. Whereas with the zone map, like we clearly saw, in here it took 1, 2, 3, 4, 5, 6. I mean, the list could go on movements to get what I need. Whereas here, you can achieve the same things in just 1, 2, 3 hops, and you skip a lot of unnecessary scans that you don't want. All right, this is what databases do behind the scenes, right? They take that data. If you have your data structured, it can allow the database to scan more efficiently and give you the results quickly than if if it's not if you're not using the right structures underneath. All right, guys. So I hope this was helpful. Indexes versus zone maps. This is what it looks like. If you have any questions on this, hopefully this was helpful to you. Let me know in the comment section below. If there are any topics you want me to make a video about, don't hesitate to drop that comment into the comment section, and I'll see what I can do about that. This has been Thru. Thanks for watching, and I'll see you in the next video.